Let us apply the theorems that are based on parallel lines by looking at question 1. The question says here that in the diagram below, AB is parallel to CD and BD is produced to F such that CE is parallel to BD. Now what we have here is that we have line AB being parallel to line CD, and we can see them by those small arrows. We further have also line BD. We know that this is a line BD. They say is produced to F. That means it is extended so that it goes to point F. And when that happens, we then have CE to be parallel to BD. So, we use double lines here because, already we have parallel lines this side. And so we have other parallel lines this side here. And the other thing that we need to note is that we sort of have angle CDF, meaning this angle here, to be 95 degrees. Now, I think we can be able to answer this question. I mean, there's a lot of things that we see here that speaks to the theorems that we have done. If we look at question 1.1, they say calculate the following angles. Under 1.1.1, we are required to look at angle B. Now, on the diagram, angle B is this angle here because, there's a vertex here that makes that angle. In order for us to get this angle, what I see from my side is that I see an F shape that is looking the other way around. There's an F shape that is sort of looking upwards, if I may say, put it that way. And we know that when we have an F shape, we actually have corresponding angles, meaning this angle and this angle should be corresponding. And they must be the same because, these two lines are parallel. So this is to say these two lines are parallel, and this actually, the line BD or BDF is actually a transversal. Now, let us go and answer this question here. Question 1, and we are doing 1.1. Under 1.1 we have 1.1.1.1. I will say here that angle B is the same as angle CDF and actually is equals to 95 degrees. So I'm saying this angle B is actually 95 degrees. This angle and this angle are the same. Now, the reason why I say that, or what makes me to say that, is because I can see that we have corresponding angles since line AB is parallel to line CD. Do you see that line AB is parallel to line CD as we were discussing? That's why those two angles will be the same when we have a transversal there. Now, that is to say here we also have 95 degrees. The next question, 1.1.2 says we should find the angle BDC, meaning this angle here. Again, for me, when I look at this, I see a U shape here. And with a U shape, we know that we are going to have angles that are in the inside of the U, the inside U, and we call those co-interior angles. And these angles must be supplementary because these two lines are parallel. They must add up to 180 degrees. And that's exactly what I'm going to do here to say, under 1.1.1.2, I will say here that angle B plus angle BDC. So we're saying angle B plus angle BDC, these two angles, when we add them, they must actually be equal to 180 degrees. And the reason for that is that they are co-interior angles because line AB is parallel to line CD. These two lines are parallel. They'll make these two to be co-interior angles because there's a transversal there. And I can then substitute my angle B, which I know is 95. We just calculated that. So this will be 95 degrees plus angle BDC, which is what we are looking for really. And we are saying this is equals to 180 degrees. This is the same as 180 degrees. Now from here, this question becomes very, 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 very boring, because we are going to transpose the 95 so that it goes that side. And we have here angle BDC being equal to 180 degrees minus 95. And we can all see that therefore angle BDC should be equal to 85. I see 85 here degrees. So that means our angle here is actually 85 degrees. Now the last question says that we should find angle C, this angle here. Now what I see on my side on this diagram is that I see a Z shape here, and of course these two lines CE and BD are parallel, we are told in the question. It therefore means they alternate angles, meaning when one angle is on the right of the vertex, the other angle will be on the left of the vertex. That's why we say they're alternating. So those two alternating angles must actually be equal. So now that means for me to answer this question, I'll say 1.1.1.3. I would say here that angle C, which is what we are looking for, is exactly the same as angle BDC. It's exactly the same as angle BDC, and they must actually be equal to this 85 that we calculated here. So this will be equals to 85 degrees. The reason would be alternate angles, right? Because we have line CE being parallel to line BD. CE is parallel to BD. And that's how you will actually find the last angle there, C. Of course, there are other ways in which this problem can be solved. Please let's share those other methods that you see for solving these problems in the comment section.